good. Okay, so we will be going over our assignment, and we're still dealing with exponents, growth, and decay. And maybe we'll get to inequalities. All right. Where's the noise coming from? Is that you, Audrey?
Yes, good evening.
Hello, is that you with the noise?
Yeah.
Where are
Okay.
the pages?
No, it's pens.
Oh.
Pens. Sure, you're looking for.
Okay. When you see, when you have that, just go to mute. Okay. Is anybody talking in the background there, Audrey?
No, it's my son. Let me close the door. In
Okay.
his room.
Yeah, because I can hear the talking. Yeah.
Sure, you know your voice a little bit.
Okay. All right. Let's get started. Now, Marie, you did the first one and you did it correctly. So tell us how you did it. Number one.
Really?
Yes, Maureen. Evaluate numbers 1 and 2. Write the answer as a single number without exponents. So you just sent it to me today and I checked it and you definitely had that one correct.
I do all the rest myself, but Audrey helped me with 1 and 2, but I do all the rest myself.
Oh, okay. So,
Audrey helped me with 1 and 2, and I do 3, 4, 5, 6. And the
oh,
rest
so you
myself.
didn't do one on your own?
No, 2, no.
Okay, Audrey, you want to tell us how you did number 1?
But I do 3 and 4 and 5 and then by myself.
Okay, let me go.
How do you do number 1, Audrey?
But when I said it like that, I get confused.
Bigger.
Okay. Oh, that's right. Sorry about that. Let's make this bigger. So, all right, Audrey, go to mute. Go to mute when you're rattling. Okay. All right. Let me make this bigger. Okay. All right. So, Audrey, tell us how you. Okay. Tell us how you did number 1.
Okay, I did the numerator first.
Okay. For number 1, what did you do? Numerator.
I do it separate. I do the numerator first,
Okay. So.
and the powers, I multiply the 2 by the powers.
And
I get 16 because 2 to the 4th power give you 2 times 4 by 2 by 2 by 2.
Okay, so let's just put this here. Okay. So you got, okay, so that's minus 2 by itself 4 times. And since it's a positive exponent, it's going to be a positive result. So what did you get?
16.
Okay, so you got, this was equal to 16. Okay. Now, what did you get for the denominator? Let me just.
The denominator, I get 169. I says 2 to the 3rd power is 9. 2 9s will be 18 plus 2 to the 2nd power is 4, and 4 2s is 8 when I multiply it with the powers.
Okay, so let's just take it step by step. Okay, so I'll move this over. Okay. Okay, now 3 to the 2nd is what?
3 to the 2nd is 18.
3 to the 2nd? 3 times 3?
Yes, 3 times 3 is 9, and you
3 times 3 is 9. Okay, so this is 9.
Right.
Okay, because you said 18. Okay, and what's 2 times 2?
That's 4.
That's 4, right? Okay.
And then you add them together.
Okay, we add those together. Well, let's put our 2 here because that's raised to the 2nd power, right? Maureen, you following what she did?
Yes, and I write it down too.
Okay, all right. So this is equal to, okay, 16. Audrey said she added 9 plus 4, she got 13.
Uh-huh.
So this is 13 to the second power, right? So let's just put that's 13. And raise that to the second power, right? Right, Audrey? That's what you did?
Yeah. Mm-hmm.
Okay.
And you
All right. So let's just take out this. Okay. And 16. And what's that equal? That's just equal to 16, right? So this is equal to 16. And 13 to the second power was what, Audrey?
169.
169. Perfect. Okay. 169. Let's just put that there. Okay. And I'll move this over. And take out the underline. You don't need it. The underline. You don't need it under the equal. Okay. And 16 over 169. And that is that what you had, Maureen, right?
Yeah.
Okay. So let me just bring this up a little closer. And that's your answer. Your answer is 16 over 169. So answer 16 over 169. And I'll make that bigger.
Who is man the one? Birthday? Mm-hmm.
Who is Monday one?
I don't know.
I don't either. Monday one. Who's Monday one? Monday one? Is that Clara? Or Chastity?
Sorry.
Who is Monday one? They're there, but they're not speaking. You're on mute. Monday one.
Good afternoon, everyone. Is it
Oh,
me?
that's Chastity.
No.
Chastity, you're Monday one. Rename yourself.
Cassidy, don't do that.
I don't know how to do that. It just comes out. I don't know.
Oh,
Rename yourself to
Where
your
do I
name.
go? I don't know where to go.
You don't know how to rename yourself?
No.
Because see, to get credit for the students on, they should have their name.
Oh, really? Well, how do I
Yes.
go?
I mean, not for you to get credit, but for the program to get credit.
No, that's very important. because-
Yes. And
Oh, wow. I didn't know.
Latoya, how does she do a rename?
I don't know, maybe she has to put
Where's
maybe-
Mercedes? Mercedes always does her rename.
Mine is always in, so I don't know, I never had that trouble.
Yeah,
Maybe she need to.
because if you do it at the beginning, you don't have to do it, but you can rename it.
No, I did it before. Even on my phone, you told me the other days I have to do that. I don't understand why it keeps on coming out like that.
Well, if you do it at the beginning of the Zoom, like I did mine just once and it come up, Barbara
So that
Day
means that
Tutor.
last time. So that means last time it didn't count either.
Well, mine come up
Probably
the
you have to
same
delete and
because
start again.
yeah, when you get on again, that's
You
right.
have to delete it. delete it
Yeah,
then
because you
and-
can do it at the beginning of your Zoom session, then it
listen to the
stays
college
there until you change it. Because I did mine just once and it comes up every time. Otherwise, Miss Becca's would have to do mine. So
do I
I
have to
did
do it
mine.
every time?
So you
I
gonna
have
take-
to do
take
You
it
don't
out.
have to do it every time. If you do it on your Zoom at the beginning, then it will stay there. Latoya doesn't do hers every time. Audrey,
Okay, all right.
Maureen, right? You just put it.
Mhm.
So whenever your
I do
Zoom
mine now.
comes up, that name comes up.
Yeah.
Yeah, I
Okay.
never had a problem like that.
No. Okay.
I'll see if I log off and log in.
And then when it says it gives you a place to put the name and you put your name there.
Okay, I'll try to do that. No,
Okay. All right. So 16 over 169 is the answer. Maureen, you okay with this?
Yeah,
Yeah, you just apply the exponents to the numbers. You know, -2 times -2 times -2 and -2. But remember, when you have a negative number, remember the rule, a negative number, positive power, your answer is positive. Okay? If it were I'm sorry, if it's a even number. A negative number, even number power, positive. Odd number will be negative. All right. Okay. And you just 3 to the seconds, 9, 3 times 3, 2 times 2 is 4. Like Audrey said, add those together, 9 and 4, 13, raised to the second power, 169. And this cannot be simplified anymore. There's no number
Mhm.
that divides into both of these numbers and give you a whole number. Okay. All right. Maureen, did you do number 2? I'm sorry. Did you do, yeah, number 2?
no, Miss.
This is number 2 right here. It's coming up 1, but it's 2. Did you do that one, Maureen? No?
No, Miss Bible.
Okay. Let's see. I think you can do it. What's 4 to the 0 power, Maureen? Any number to the 0 power is what?
0
No, 1.
is 1.
Right. Any
Okay.
number of variable to the 0 power is 1.
1.
So that would be 1. And I'll put an asterisk here. Okay. What's 2 to the second power, Maureen?
2 to the second power
Yes,
is 4.
that's right. 2 times 2. Okay. Okay, so you got 1 times 4, right? So let's go to the denominator. That was the numerator. Let's put that there. What's 3 to the first? Oh, I'm sorry. Let me make this bigger. Sorry, Audrey. Make that bigger. Okay. Now, what's 3 to the first power, Maureen? 3 to the power of 1. What is that?
3.
What?
3 to the first power is 3.
That's right. Very good. Okay. And we've got multiplying. I'll put an asterisk again. What's 4 to the second power?
16.
16. Okay. Okay, so let me make this all bigger. Okay. Now, Maureen, what's 4 times 1?
4.
4 times 1 is 4. Okay. So let's just put that there. 4 times 1 is 4. And what's 3 times 16?
48.
48. Okay. Now, simplify that. In other words, reduce it to its lowest term. What's 4 over 48 equal to?
4 to 4, 1. 4 into 48 is 12.
That's right.
1,
So this
1,
becomes
1
this.
12.
That's right. You got it. So that's equal to 1 over 12. So let's put the 12 here. All right. Let me bring that up closer. Okay, here we go. And we don't need the we don't need the underline under the equal. I'll just put that there and take that out. And we don't need it here under the equal. And that's your answer, 1 over 12. Okay.
What does the star mean in between the 1 and 4?
Oh, that's an asterisk. That's the time. I sometimes use asterisks for time symbols. You know, the symbols
Not
for multiplying, Chastity, or asterisk, dots, the X, or it could be parentheses.
Okay.
Okay, those are different ways of expressing multiplication. So it's a multiplication symbol. 1 asterisk 4 means 1 times 4. Okay,
Thank you.
got it? Okay.
Yeah.
So answer 1/12. So any questions on number 2? You're doing is taking the numbers and applying the exponents and simplifying them. Okay, see, if it were variables, if this was x to the 0, it would still be 1, right? And if this was x to the second, it would just be x times x. Any questions on number 2? No questions? So we'll go to number 3. Latoya, what happened to you on number 3?
I don't know.
Audrey, what happened to
think
you
the
on
answer
number
was
3?
C. I thought the answer was C and I put D. D.
Audrey, you
I
did.
had B first and then I put D.
The
Okay,
answer is C. I think the
answer
answer is
is C. That's
C.
correct.
Yeah, and then I write foolishness. I was like, what? How the hell I put D?
1,
I know it was
2,
C. My spirit tell me it was C.
Yeah.
My,
2, 4, 3.
So,
but it,
Latoya, you said C. How do you get C?
I guess, Miss Barbara.
You guess?
No,
Yeah, I didn't know
X,
to do
X,
it for real,
is
to
2.
be
X
honest.
is 2. And 2 times 4 will be 8. Yeah.
What?
I just look at it and said,
You
2
just
to the
get.
X.
Okay,
I
so you,
just guess that one.
so you say you guess. Okay, let's just put it here, and you don't have to guess. You can figure it out. You can see something. Just look at these numbers. What factor do they have in common?
2.
2.
2. All right. So you got a good start there. That means now there's a 2 there, 2 to the x. So 4 to the y power. Let's put that there.
Y is 4, so Y is 4. Okay.
Okay. Okay. So 4 to the y power. Let's put that there. Now, what can that be expressed as, Audrey?
4.
No.
4 to the 1
1.
power. 4 to the
4 to
1.
1 power.
No. You said they had 2 in common, right?
Right, 2, 4. Yes, 2 Y's is 2.
So using the 2, how can you get y? What power?
Second power.
4. 2 to the 4 power.
No, that's too big.
0.
No, 2 to the 0 is 1. So
To the second power. 2 to the
second power. That's right. That's right. So 4 to the y is equal to 2 to the second power y. Right? Because 4 is 2 times 2. Got it? 2 to the second is 4, and then the y is the exponent because this was a y. So 2 to the second is 4. And so that would be 2 to the y. Now, since I did that for the 4, now you tell me what the 8 would have to be. Let's say 8 to the z.
3Z.
What would it be?
3Z equal 2 times 2 times 2.
You mean 2 to the 3.
Yeah, 2 to the 3, yeah.
Right, that's it, Latoya. Very good. So this would be equal to, let's put this here.
I should have get that right. I had it right there. I was able to put a different one.
Yes. So let's just copy that and put our 3 there because 2 times 2 times 2 is 8. So let's put
Oh,
that there.
damn. Oh. Oh,
Okay.
man.
So that would be a 3 here, right? So let's just put 3, 3Z. Got it?
I was working for my 100 or something.
I know you were because the inequalities were bonuses because like Audrey, I remember Audrey said she didn't really understand that so well. So I said, well, not going to penalize the ones who don't get it right. It's a bonus. If you get it, if you don't, it's not taken off your grade any. Okay, so we've got 2. Now we've got what? let's just take this. This 2 to the x is 2 to the x, and this is 2 to the 2y, and this is 2 to the 3z. So now I will put this all on the next screen, and I want you to put it all together. Okay. So this, let's just copy this and then put in what we have expanded this to be. Okay. So here we go. So 2 to the x stays to the x. 4 to the y becomes what? 2 to the 2 to the y. 2 to the 2 is 4. So let's just put that there.
Hmm.
Okay, so let's put our 2 to the 2y here. 2 and put our 2y. Okay, so that's 2y, right? And our 8z is 2 to the 3z. So let's put our 2, take the 8 out, and put our 3. So that's and I'll put my 3z there, 3z. Okay. Now, what's the rule for exponents?
When you multiply,
You add?
Yeah, you
when
add the powers,
exponent.
right? So our answers here, you see the answers there, right? So you have the, let's go back here. You have the x plus the 2y will be equal to 3z, right? Because you add the powers when you're multiplying. So that x plus the 2y is equal to 3z. And that's exactly what C has right here. There you
Mhm.
go. See it? Put
I
that.
had that at first and then they changed it.
You changed it? Okay.
Right? Let's put
Well,
on
because you
this
can
one,
see
that's
they
what-
had two, the twos were in common for all of them, right? So
Mhm.
add the exponents. X plus 2y equals 3z. And that's your answer. Questions? See, when you look at this, let's go back up here. When you looked at 2 to the x, 4 to the y, 8 to the z, you know that the factor that 2 goes into is 2, and 8 is also 2, because 2 to the third power is 8, 2 to the second power is 4. So all you do is substitute your 4 by 2 to the second, substitute your 8 by 2 to the third, but you keep those variables. Okay, and then you just apply your rules of exponents. What do you do when you multiply? Add the powers. Any questions? So that's answer, what was that, C? Questions on that problem, number 3. So Latoya, you said you guessed, now you know how to do it, right?
Yeah,
Okay,
my guess was right.
yeah, but you didn't put that guess down.
No, I was mad when I got it wrong.
So then
Why
the
didn't
next-
you put it down? Latoya?
I had seen they changed it to D2, so then
You changed
But-
it? Oh my
Yeah.
goodness.
Okay,
Because
Miss Barbara,
sometimes
change it to my name.
What is it, Chastity?
yeah,
Oh, I see you got your name now. Very good.
Oh, that's
Chastity,
easy.
you have a question on this number 3?
No, not really.
But did you notice when you looked at this that the 2 was the common multiple here? 2 goes into 2, 2 goes into 4, 2 goes into 8. So remember, when you can get this as a 2, you can add the exponents, right? Same base, add the exponents, right?
Yes.
Okay, so we just made the 4 2 to the second, but we can't throw away the y. We have to keep that y. All
Yeah,
right?
I'm sorry. I logged off for a little bit because I want to see how you change the name, but you don't have to log off. You just have to go into the participants,
Oh,
and it
okay.
shows you right there, and then you click on the name and then you change it. So it is, you don't really
Very
have
good.
to.
Okay, very
But I
good.
logged out. I didn't think I don't know. I didn't know how to do it. So
Okay, very
Alright,
good. So we
thank
are
you.
learning something. You don't have to log off. Just put in where your name comes up, change it to what your name is if it's not the right name. All
Yeah,
right.
thank you.
Okay, so that was number 3. Okay. Number 4. Audrey, did you do number 4?
Yeah,
What was your answer?
11 over 12.
11 over
B.
12. Yes, you want to tell us how you got it?
Okay, it says a to the second over 3 and a to the 1 over 4. And then I calculate it.
Okay, well, what did you change that 8 to this 2 over 3 to?
Because it is a to the second, and that says divide by 3. That's why I think that is a 3. So I put that as a denominator.
What did you put as a denominator?
The 3, a to the second power over 3. If that's
But
what it-
but didn't you convert that to something with a 12? Because 3 and 4, the
3,
least
4,
common
yes,
denominator is 12, right? So 2 over
yeah.
3 is what over 12?
And 8 to 1 over the 4th, and 8 to 1 4. Yeah, 8 to 1 over 4. That's what I did. That's how we get the 12.
So
8 to the second over 3, and 8 to the 1, 8 to the 1 over 4. That's how I did mine. And then I multiply the 3 by the 4 in the denominator section, and I get 12. And then I multiply, oh no.
okay, a to
Let
the
me see
2
again.
over
I can't-
3. That's what over 12, Audrey? What's the
Huh?
exponent over 12? 2 over 3 is what
11.
over 12?
11.
No. It's 8, isn't
Is
it?
8? Okay, get
Yeah.
8.
4 times 3 is 12. 4 times 2 is 8. Correct?
Oh no, I know. Yeah. I didn't do that. I can't.
You
I
have the
cancel it
right
out.
answer, but I was trying to figure
Yeah,
out
I
what you
cancel
said
it out.
you were doing.
You see, 8 to the second, I says 2 into 2 is 1. Okay, and 2 into 4 is 2. I think
Okay.
I did.
Now,
Let me see what that is on. No, 2.
no, 2 over
No,
3
think that-
is
yes,
8 over 12, right? 4 times 2 is
Yeah.
8. 4 times 3 is 12. Now, 1 over 4 is what number over 12?
1 over.
It's 1 over
Mhm.
4. What is that equal to over 12? What I'm asking you is 1 over 4. That's equal to n over 12. What is n?
1.
No, how do you go from 12 to 3? What do you do? What do you multiply by?
4. 4 by 3.
Yeah, 4 by 3 is 12. So 3 times 1 is 12. So 1 over 4 becomes 3 over 12. You're just expressing both powers over the same denominator. So then when you add the 8 over 12 plus 3 over 12, you get 11 over 12,
Yeah.
right?
Yes.
That's what you did.
Thank
You made your denominators the same. That way you could
Okay, yeah,
add them. All right. You can't
Yeah.
add the 2/3 to the 1/4 because to add fractions, your denominators have to be the same. So this would be equal to
yeah, okay, yeah.
A over 8/12 plus 3/12, and
Over
that
12.
would give you 11/12.
Yeah.
Maureen, did you do that one?
No.
Well, you understand now how you go from 2/3 to 12s and you go to 1/4 to 12s. And then you can, since they're all in 12s, you can add them because 8
them,
plus 3 is 11.
Mm.
Got it?
Yeah.
Okay. Because remember, you can't add these fractions with different denominators, right? You can multiply them, but you can't add them.
Multiply them, yeah. Yeah.
But the rule for exponent is
Yeah,
multiplication. You
So
add
multiplication, so
the
yeah.
powers, and here the powers are fractions. You add the 2/3 and the 1/4, but you can't add them as they are because the denominators are different.
Denominations are different, yeah.
Now, Chastity, this dot right here is multiplication. See, we use asterisk, we can use the dot. That means A to the 2/3 times A to the 1/4. So your rule for multiplication is to add the powers. Got it?
Yeah, I noticed, yeah.
Okay. All right, let's go to number 5. Let me make this bigger. Audrey, did you do this one?
Number 5,
Yes.
yeah.
Okay. Now I'll go to the next page so we can put that all together. Oh, okay. So Xavier bought a painting for Javier. J is H in Espanol, right? Javier bought a painting for $150. Each year, the painting's value increases by a factor 1.15. Which expression gives the painting's value after 7 years? Now, what do we do with that factor?
We change it to decimal. That's why decimal.
What do you do?
Multiply it.
We add.
Multiply it by the years.
What do you do, Latoya?
We add.
Add what?
The value.
What? So what's your answer?
Is B.
No. A factor is always multiplied. And the power is the time. You see, this one, it says increases by a factor of 1.15. So this is like you went up by what? 15%, which is 1.5, but it gives you the factor already. So it's not like it's giving you a percent. So that means you multiply that factor and you have to raise that factor to a power, and that power is the time. And the time here is 7 years. Here's the time. Got it? There's the time.
Which one is it? C?
So your answer is D?
Answer is D. You raise the factor to a power, Latoya.
So what's the difference between C and D?
C.
So got the parentheses and yeah.
Well, look, Latoya, this has parentheses around the multiplication. With the power should only be on the factor.
No.
Right? Power should only be on the factor. And now we had been looking at some with percents or whatever, but here they give you the factor. In other words, they took the percent, added it, made it a decimal, added to 1, and it got the factor. So you just raise that to the power. That's the time, and that's 7 years. So the original, when he bought the painting for $150, times the factor raised to the power that's equal to the time, that's 7 years, that would give you your answer. So your answer should be D. That clear, Latoya?
Yeah.
Remember, these are not, they're never plus. You're always multiplying your original by a factor. And sometimes you find that factor when you're given the percent, right? You add 1 to the percent as a decimal.
Mm.
But this time I gave you the factor. You didn't have to calculate it. See, I could have said, oh, it increases by 15%, and then you would have had the 1 plus the 1.5 and raised that to the power. Okay.
Okay.
Questions on number 5. Did you have that one, Maureen?
I
You did-
correct it when you say, but my answers to me had correct it.
Okay, so you corrected it. Okay. Audrey, you had that one correct?
No,
You did the
I don't
add
think
too,
so.
right?
I think I did add, yeah.
Yeah, I think that was a common mistake to add. Okay. All right, let's look at this expensive pocketbook. Who pays 20,000 for a pocketbook?
Donald Trump.
Louis Vuitton on 35,000.
What does Louis Vuitton cost, Latoya?
25 to 30,000. For the
Really?
small one, yeah, the vintage one.
One of
That-
the
that's what
Kardashians and then
came
just
from
buy them things.
A Louis Vuitton bag costs 35,000?
Of
Yeah.
course, they did one of the Kardashians and the Trumps.
The
and
one
they just
with
buy them things.
diamonds. The one with diamonds. They have one that make with pure diamonds.
I had to buy
Could go
fake
for
ones.
100K too.
I would buy
Maureen, what did you have for number 6? Maria paid 20,000 on a pocketbook, and it says it decreases exponentially. In other words, it depreciates.
I had
So,
air for my answer.
so, and you exactly right, because if it depreciate, you're gonna subtract the rate from 1, 8% change to a decimal 0.08. And you subtract that from 1 and you raise it to the power that's the time. So the answer would be A. Wouldn't be added. Depreciation, you subtract, right? But you subtract the rate, not the time. See, C has the time, right? So the answer, like Maureen said, is A. Answer A. Any questions on number 6? Now, Latoya got the value of it. Latoya, tell us how you got the value of the pocketbook
I
after
said
5 years.
20,000 outside parentheses 0.92 close parentheses 5 at the exponent.
Where's she getting 9.2 from?
Okay, so let me write what Latoya said. So Latoya, what did you have?
I have 20,000 outside the parentheses and 0.92 close parentheses and 5 at the top.
Okay,
And it gives you $13,181.63.
so you had
You subtract the
20,000.
one within the
180.
Within
163.
yeah, you
what was
subtract
the,
1 minus 0.08 and you get 0.92.
that's right, 0.08. And that's raised to the 5th power, right?
Yeah.
Okay. So the value, okay, the V after 5 years would be equal to the 20,000. And remember, we said we subtract the percent as a decimal from the 1. It's raised to the 5th power because it says 5 years. That's the time, right?
Yeah.
So when you did that, Latoya, what did you get? Let me copy this.
It's 0.92 for in the middle. You do
Okay.
parentheses first.
Okay. Okay, so let's just copy this. And 1 minus 0.08, you got 0.92, right? So this is
Yeah.
0.92. Let's just put that there. And 0.08 from 1 is 0.92. And you can put it in your calculator and get the power of point. Now, does everybody know how to put that in their calculator?
I didn't do that. I don't mind like that.
You didn't do that, Audrey? Well,
I just put one. I put my 2000 outside the parentheses. And I put the one on the inside and subtract the 0.08% times the 5.
well, how did you get the 0.92 to the 5th power?
I don't know. I didn't get that.
You didn't have it set up like this?
I want to do the first part with the 2000 inside the 1 minus the 0.08 in parentheses, and then the 5.
You didn't put to the 5th power, the time?
Yeah, the 5th power.
Okay.
And then I get out 18,131.63046. That's what I get out. But then I didn't work out the
How did you get
value of the
18,000?
pocketbook.
How did you get 18,000? 0.92 to the 5th.
Sorry, it's 13. Sorry, it's 13,181.63.
Yeah,
I think
that's
that's
correct.
it.
So this 0.92 to the 5th power, you should have gotten
How do you get that?
0.65908. Let's see, 65908. Okay, when you raise the 0.92 to the 5th power. Now, Audrey, you asked, how do you get what?
The 0.925, 0.92.
0.08 subtracted from 1, Audrey. Can you subtract 0.08 from 1?
0.08.
Yes, subtract that from the number 1.
Let's see. Okay.
In other
So
words,
take one.
take 1, take the number 1. This is what Latoya did.
0.08.
0, subtract
Oh,
0.08
yes, I get
from
it.
it.
0.92. Yeah, get
Okay,
0.92.
you got it? Okay, okay. So, and then
That's what she did.
yes, that's what Latoya did. And her value, let me just put her value here. And the value of it after the depreciation, and she got 13,181.63. Right, Latoya? That was your answer.
Yeah. Yeah, that was my answer.
Okay, Audrey, did you get that? Audrey, did you get that answer? So what did you?
Oh, yeah, yes, I get that.
Yeah. So
13.
you,
Yeah,
okay,
I got that. I know how
13,000.
she did.
So Audrey, what's the question?
No, I was saying that it says what is the value of the pocketbook after 5 years. And you said give your answer to the 100th decimal place.
Yeah,
So I was saying that.
0.63. That's the hundredths, right there.
Right.
Tenths, hundredth.
Yeah, it's 13.181.63. Yeah.
Okay.
Okay.
So what was your question you were
saying.
asking, Audrey? What's the question?
Huh?
I thought you were asking a question about what Latoya did. You got it?
I was asking about how to get that 92. That's what I was asking.
Okay, so you know now, subtract the 0.08 from the 1.00 and you get 0.92. Okay, then raise the 0.92 to the 5th power, Latoya got 65908 multiplied by 20,000. That pocketbook that was 20,000 in 5 years is worth 13,181.63. And I guess people do sell those at resale shops, right? They sell them at resale shops.
Yeah, they auction them off sometimes.
Yeah, they auction them off. But now some things increase in value, right? Even though they are old.
Yeah,
What makes them increase in value? Anybody? What do you think makes them increase in value?
because sometimes that's like that they did it for charity or something valuable. Sometimes they could have a Louis Vuitton like 20 years ago, but the value of it when you buy it from it depreciates. But then if you auction it to some funding of charity or whatever, if they increase it more, you could get up to $30,000 people will buy it for. You could pay
Yeah,
20, but when
That's
it
if, that's
add
if it ain't
value
got
when
the
you do
rares, nor the tears.
auction. Yeah, the people them that you give it to auction, they add more money to it.
yeah. And also, sometimes when there's a limited number of things made, it becomes a point where you don't have too many left. So that increased the value.
Yeah.
Yeah, that can increase the value, the scarcity of something. And somebody really want it, they'll pay money for it, right?
Yeah.
Okay. All right, let's go to number 8. That was 7. Okay, now we're into inequalities. Now, inequalities work just like equals. I mean, you solve them the same way, except the symbol is an inequality, not an equal. If this was 5x, let's just put here, if this were 5x equal 10. Audrey, is that you rounding?
Yes, sir. And let's just move it.
Okay. Now, 5x equal to 10. Now, this just mental math, you know the answer, right? What's the answer, Maureen?
2.
2, because 5 times 2 is 10, right? Now, if this is an inequality, you solve it the same way, right? So 5x greater than 10. Let's just put that there. Solve it the same way as if it was an equality. So, Maureen, how would you solve this?
I would divide 5 into 10.
Yes, you divide 5 into 5x and 5 into 10. So your answer would be, because what you're doing, you're divide both sides of the inequality by 5. So what do you have on the left side? 5x divided by 5 just gives you x, right? Make that bigger. So that just gives you x. So you'd have x, and then you divide the 5 and the 10, and so you'd have what? 2. So that'd be greater than 2. So your answer would be x greater than, this would be a 2 here. 5 and the 10 goes 2. So what answer would that be, Maureen?
A.
A. That's right. That's your answer. So answer A. So just remember, with the inequalities, same rules as if they were equals. Same rules, okay? What you apply to one side of the inequality, you apply to the other side. Make that bigger. Okay, so that's answer A for 8. So let's go to 9. Audrey, how do you solve 9?
I know, cause I do it.
You didn't do number 9?
Wrong. I do it wrong. I do all wrong. Cause I never really.
You did them wrong? You did the first one wrong?
I think I did all of them wrong. I think so.
Okay, let's go back up to So what did you do for number 8, Audrey?
Number 8, I had C.
How did you get a -2?
Look at it, put C.
Yes, but how did you get C? X greater than -2.
Because they didn't understand it. They just guessed them all. Didn't
Okay,
really understand.
yeah, but remember I just said 5x greater than 10. Audrey, you still rattling?
No, that's not me.
Who is that? Somebody's rattling. Okay, so if it were equal, 5x is equal to 10. How would you solve for x, Audrey? How would you solve 5x equal to 10? How would you solve for x? Well, this one's mental math, you can see it, but how could you solve it mathematically here?
Subtract the 5 from the 10.
No. 5x means 5 times x. What's the opposite of multiplication, Audrey?
Division.
Division. So you divide both sides by 5. 5x over 5 give x, and then 10 over 5 gives you 2. So that means x equals 2. Got it?
Mm-hmm.
So when you're trying to solve for this variable, you see how is that variable connected to the number? It's connected by multiplication. So just to get the variable by itself, you have to do a division. So divide the 5x by 5 and divide the 10 by 5. Okay, now for inequalities, it's the same thing, except it's an inequality. 5x greater than 10. Divide both sides by 5. But you don't have an equal here. You just keep that inequality sign. So 5x divided by 5 is just x. And then 10 divided by 5 is 2. So your answer will be x greater than 2. Got it?
Mm-hmm. I think so.
Because, okay, let's think about this, Audrey. What if x is 2 right here for 5x greater than 10? If x is 2, 5 times 2 is 10, but 10 is not greater than 10, right? But if x was 3, 5 times 3 is 15, 15 is greater than 10. So this becomes true only when the x is greater than 2. Because if it's equal to 2, then you'll have 10 equal 10, but that's not what it's saying. It's saying 5x is greater than 10. That means x has to be 3 or higher, right?
Okay.
In order for 5 times some number to be greater than 10, that number has to be greater than 2. Because if it's equal to 2, then 5 times 2 is 10 and they're equal. But that's not what we're saying. We're saying 5 times some variable is greater than 10. So that means when we divide by 5, we get x greater than 10 divided by 5, x greater than 2. And that's what we just said, right? We just said that it has to be greater than 2. Got it?
Yeah.
Is it clearer now, the greater than?
I
Okay.
think so.
Okay, well, wait, let me give you another one here. Suppose you had, okay, 6y, and let me put, okay, and I'll put greater than 6y greater than 12. Now, what can be values of y so that 6y is greater than 12, Audrey? What could be values of y?
I'm sorry. Not answered maybe.
Four.
Audrey? Audrey?
Mhm.
Oh, Chastity, you were answering?
3.
It says 4.
Yeah, it could be a
am.
3. Yeah, it could be a 3. It could be a 4. In other words, it has to be greater than 2, right? Because 6 times 2 is 12, and 12 is not greater than 12. It's equal to 12. But if you put a 3 here, 6 times 3 is 18.
Oh, no.
18 is greater than 12. If you put a 4 here, 6 times 4 is 24. 24 greater than 12. So any number greater than 2 would give you 6y greater than 12. So y can be any number greater than 2 to give you greater than 12.
Okay.
Okay.
Is it making sense now?
Yes. Yeah.
Okay. So when you look at something like this, you say, well, what could be values of this variable y for me to get 6 times that value greater than 12? It can't be a 2 because that would be equal to 12. So it's got to be greater than 2, right?
Yes.
So greater than 2, and they don't have to all be whole numbers. 2.1, 6 times 2.1 is greater than 2. So any number greater than 2 would satisfy this inequality. Got it?
Yeah.
It's making sense now, Audrey? Because I know you said before
Yes.
that this inequality wasn't making sense to you. Okay.
Yeah, it's confusing.
Okay.
So
Okay.
we-
Okay. So let's go to 3x plus 2 greater than 8. Now, Latoya, how would you solve this one? 3x plus 2 greater than 8.
Yeah, I did minus 2 on both sides.
Okay, so let's just copy this and do what Latoya did. She subtracted 2 from both sides, just like you do if it was an equal, right? Subtract 2 from both sides. Okay. Now let's just do that. Take this 3x plus 2 greater than 8. Subtract the 2. So minus 2 on the left and subtract the minus 2 on the right. Okay, Latoya, what did you do next?
And the 2's cancel out.
Okay, plus 2 minus 2 is 0 or cancel. So you left with, just copy this. So you're left with just 3x on the left side, right? Because like
Yeah.
Latoya just said, those 2's add up to 0 or cancels out. And what's 8 minus 2, Latoya?
6.
That's 6. Audrey, you with us?
Mhm.
Okay.
Yes.
Maureen,
Yeah,
Maureen, you okay?
yeah,
All right. So 3x greater than 2. Now, what could be values of x?
1.
Latoya, what did you just say?
3 divided by 3 on both sides.
No, you didn't answer my question. What could be values of x so that 3 times it gives you something greater than 6?
3.
Yeah, it could be 3, right?
Yeah.
So based on your choices, what would satisfy this being greater than 6? 3 times what?
9.
Yeah,
3
3
times
times
3 is
9.
9.
So what answer would you put here? A, B, C, or D?
D.
That's right. In other words, it has to be greater than 2. Because there again, 3 times 2 is 6. That would be equal. So it has to be greater than 2. Questions? Questions on number 9? Audrey, is that clear to you?
She said that the 3x, something with 6 is 9.
Oh, shit.
No, no.
I don't understand that. I don't understand that
Okay.
one.
Okay. 3x plus 2 greater than 8. Now, what Latoya did, she subtracted her 2 so she get a constant on the same side. So subtracting the 2 from both sides, she gets her 2 with the 8, and that's a subtraction. So that gives you 6. Now,
Right.
once you got 3x greater than 6, my question was, what numbers would make this inequality true? What numbers, Audrey?
Okay.
What does x have to be so that when you multiply 3 times it, you get a number greater than 6?
2.
Yeah,
4.
Chastity,
4.
you said 2. It has to be, yeah, that's right. It's got to be greater than 2. Yeah, it could be 3, could be 4, but it has to be greater than 2. What choice has greater than 2? D, x greater than 2. Making sense, Audrey?
Okay. I think so.
3 times some number greater than 6. Now, you look at your choices here. It can't be less than 2 because it won't be greater than 6. This is saying 3 multiplied by a variable x. That x variable cannot be 2 because then you would have 6 equals 6, but this says greater than. So it has to be a number greater than 2. Like 3 times 3 is 9, 9 greater than 6. 3 times 4 is 12, 12 greater than 6. 3 times 5, 15, 15 greater than 6. Got it?
Yes.
Maureen, you okay? Maureen? Maureen, are you there?
Yeah,
I didn't. I said, are you okay with this 3x greater than 6? X has to be greater than 2.
I know. I got mine right when I sent it to you, sir.
Okay, you had it. Okay, very good. All right. So that was number 9, and we have one more.
So when it says solving means,
Solve the inequality means actually to give the variable in terms of the number. All right,
okay.
so you really, well, you could say it again by simplifying. So you're
Yeah.
really solving for the variable, except your variable is connected with an inequality symbol, not an equal.
Okay.
All right.
Yes, thank you.
Okay, so let's go to the last one of the inequalities. Okay, Audrey, did you have this one correct?
No.
You didn't have. Maureen, did you have this one correct? Maureen?
No, Miss
When
Brown.
was he sleeping?
You did- Okay, well, let's just go through it. Okay. It's solved similar to the one that Latoya just solved, all right? So what would you do first, Audrey? What would you do first? 3x minus 7 less than 5. What would you do first?
Okay, we would
Well, you want to get your constants together. So you have a -7 and you have a 5. How do you get the 7 over on the side with the 5? The -7. What would you do?
You add,
That's right. You add 7 to both sides. Very good.
Mhm.
So add 7 to both sides. All right. Now let's do that, Audrey. What do you get?
oh, that's
Add 7 to both sides. So let's put plus 7 on the left and put plus 7 on the right. Okay, Audrey, what do you have here on the left side?
3x. Okay, plus 7.
What's on the
Is that
left
minus
side?
3x minus 7 plus 7.
3x minus 7 plus 7. What does that equal to?
14.
A minus 7 and a plus 7, Audrey, give you what?
Oh, minus 7 and plus 7. Oh, gosh. Yeah, no, this kind of stuff I gotta look at this one, something like that. And what I'm here.
A minus 7 and a plus 7.
Okay, minus 7 plus 7, minus 7 plus 7. Hmm.
You owe somebody $7
Yes,
and you pay them $7. So what do you owe now?
Nothing,
0.
nothing.
Right.
Okay.
Minus 7 plus 7 is a 0. So this just
Okay.
becomes 3x on the left side. Got it?
Yes.
A minus 7. Think of it like you owe somebody 7 and you pay them the debt 7. Now you clear. You're 0. Okay. What's 5 plus 7?
12.
12. Okay. So let's put out 12 here. Now, Audrey, 3x less than 12. What would be the answer?
3x less than 12.
What would x be?
3.
We're solving for x. How would I solve for x? How would I solve this inequality for x?
You add.
No. How is 3 connected to x,
Oh,
Audrey?
yes, multiply. Multiply is division. Okay, divide.
So that's multiplication. 3x means 3 times
Yeah.
x. So you divide both sides by 3.
3.
Yeah, by 3.
Divide both sides of inequality by 3. And what would that give you, Audrey?
X equals 4.
Yeah.
Hmm.
Well, it's not an equal now. So less than.
Equals plus 4.
3x divided by 3 just gives you x, right?
Right, X. And then 3
And
divided
then
by
12 divided by
divided by
3 is what?
It's 4.
Okay, so 3x
So-
divided by 3 is just x. So that would just be x.
So what happened with the
And-
minus in the middle?
The what?
That's not the minus.
No, you had a minus 7 plus 7. That's 0.
Okay.
Audrey, that's 0. Remember, we added 7 to both sides. There's a minus 7 still there. Still there. We added a 7 plus 7 minus 7 give you 0. You don't have to put the 0 here. And then the 5 and the 7 adds to 12. So you divide both sides by 3. 3x divided by 3 give you x. And 12 divided by 3 gives you what, Audrey? What's 12
4.
divided? That's right, 4. So your answer is X less than 4. What choice is that here? A, B, C, or D?
Less than 4C.
C, that's right. Answer C. There's your answer. Making sense, Audrey?
Yeah, but sometimes I have to look, I gotta look back at my book and learn these little angles, these little lesson, more lesson, whatever else that is. That's what throw me off.
Yeah.
The more
Well,
than and the less than.
you've got to
Those are the
know
fun.
less than,
Right. That is what throw
greater
me off.
than, less
that
than
is
or
it.
equal, greater than or equal, not equal. Those are your
Yeah.
5
Right, formula, that's
inequality
what I learned.
signs. Yeah.
Yeah.
Less
that's
than,
yeah.
greater than, there's your greater than, greater, less. Less is that point to the left. Less. Where's the noise, Audrey? Is that you, Rowland?
No, not me, somebody else.
Somebody else? Okay,
Yeah,
Latoya, is
somebody
that
from
you?
here.
Must be Latoya.
No, Miss
Is that
Laura.
you?
No.
Maureen, is that
I
you?
can hear it. I can hear it too.
You can
I
hear
can
it,
hear it.
right? Maureen, is that you?
No, nothing in my house, period.
I don't know.
Okay. Everybody go to mute. Everybody go to mute, please. Maureen, go to mute.
I'm going.
Go to mute. Audrey, go to mute.
Yeah, I have one on mute.
No, I don't. There you are on mute. Maureen. Okay. Audrey, are you on mute?
Yeah, it says mute. I
Well,
say mute.
I don't see you coming up mute. There you go. Now I don't hear it. Audrey, unmute yourself. Okay. Maureen, unmute yourself.
On you.
Latoya, unmute yourself.
You see it here something just now. Actually on mute. Hear it? Actually on mute to hearing it.
Huh?
I think it's the toy.
To hear it. Actually on mute to hear it.
I'm not moving. What are you talking about? I don't make noise.
Okay. Chastity, unmute yourself. She might be driving.
Yeah.
Okay. Now I don't hear it. Okay. Maybe it's just intermittent. Okay. Any questions on this last one? Okay. All right. Now let's go to exponential growth and decay. I want to look at some more practice. Now, there's a very important formula called the compound interest formula. That's interest made on interest. It's called compound. Now, here's the formula. So your ending amount, your beginning amount, your interest rate, your number of times you're compounding a year, and the total number of years. Now, I don't expect you to remember this formula, but I want you to know what everything means in the formula. So what you end up with is the A right here. Wait, let me make this bigger. Okay. So what you end up with is A, right? What you're starting with is your P, beginning amount of principal. Who is talking? Who is talking?
That's G. She going out through the door.
Who?
That's G talking to her before. She going out through the door now, though.
Okay. R is the interest rate. We express that as a decimal in the number of compoundings a year, because you determine how many well, your plan will tell you how many times you're compounding during the year. Okay, could be 6 times, could be 4 times, whatever. T is the number of years. Okay, now let's make this bigger.
Yeah.
This is important. You will get all of this. I will send you all of this. Okay. Okay, if interest is compound yearly, N is 1. If it's semi-annual, twice a year, it's 2. If it's quarterly, it's 4 quarters in a year, that's 4. If it's monthly, N is 12. All right. Put this all on the next. If it's weekly, it's 52 because there are 52 weeks in a year. If it's daily, it's 365 because there are 365 days in the year.
Yeah.
Okay, so this is the values you use. Once a year, 1. Quarterly, 4. 4 quarters in a year, semi-annual, that's 6 months, right? And if it's monthly, 12 months in a year, 12. If it's weekly, 52 weeks in a year. Daily, we use 365. Okay. Now, here's an example of applying this. And most of these will really be set up kind of problems. I want you to recognize the correct setup. Now, what would be the compound interest? And let me put this all on one page. Okay. What would the compound interest be? Your investment amount is 150. So that's your beginning amount, right?
Mhm. 12.
So let's just underline that. That's 150. Okay. The interest rate
That's
is
150. That's
3.
12.
That's
I'm
12.50.
sorry, 1250. Thank you. That's
Yeah.
1250. The interest rate is 3%. So let's just underline that. Your investment period is T years. Okay. So we'll just underline that. Now, knowing what these mean, 1250, your investment, that's your beginning amount.
Mhm.
1 plus 0.03, you convert your percent to a decimal. All right. It's compounded monthly. How many months are in a year?
12.
12. So you see the 12 there, right? That's
Mhm.
12. And for an investment period of T years, that's N times T. Now, what did we say N was? If it's monthly, N is 12. So that's why we have the 12 here, because it's monthly, right? Times the T, which would be T years. So this is the way your formula would look. A equal present amount 1250 times 1 plus the rate over N is 12 because it's monthly. And the 12 here is the N, and that N, remember I gave you those values here. When it's monthly, N is 12. And then times T, the time. So divide 0.03 by 12 and add it to 1, you get 1.0025 times 12 to the T. So that's the setup. Any questions on that setup? So I want you to be able to do a setup. That means knowing what everything means in the compound interest formula. All right. Now let's take another one. Okay, I want you to try this one. Okay, let me just I want you to write the formula. I don't want you to solve anything. I just want you to write the formula. Okay. Okay. You now this one is a little different. Now you want to get $10,000. Okay. So this is not what you started. This is what you want to end up with, 10,000. So let's just underline that 10,000. Keeping in mind, that's how much you want to have in your account, 10,000. And your time is 36 months. Okay, so let's underline the 36 months time. Okay, your interest is 3.5%. Okay, so there's your rate. And you're compounding monthly. So that means how many months in a year?
12
12.
months.
Okay, so now let's just copy the formula. Go back up here, copy the formula. Okay, there we go. And I want you to substitute in the formula. Let's see. Go back to the formula. I want to copy it. Okay. Okay. Let's copy the formula. And all I want you to do is to substitute in the formula and tell me what you get. Okay.
Okay.
Now here's the formula. Okay. Okay. So I want, now remember, this is one where you're looking, you want to make 10,000. So that means then what? That means your A would be your 10,000. All right. So your A would be your 10,000. So substitute in the formula. Here's the formula. I want you to substitute in it and tell me what you get. You want to make 10,000. So that A is what you want to make. This is how much you need to invest to make it. So you're really looking for P, right? So 10,000 equal, you got P, 1 plus, what's your rate? What's your rate? There's your rate, the 3.5%. Convert that to a decimal. So that would be what? What would it be as a decimal? 3.5% would be what as a decimal? Maureen, what would 3.5% be as a decimal?
Oh, boy.
0.035.
3.5%. What did you say, Audrey?
0.035%.
That's right. 0.35. Okay, so you got that. So that's going to be your R. And what is your N? Compounded monthly. So what's your N?
Year.
No,
Yes,
remember I gave you some values. Let's go back up here. N for monthly, N
Okay.
is 12. Remember 12 months in a year.
Right.
So put your 12. 0.035 over 12. All right. There again, the N 12. And what's your T?
She's switching fast. You can't read as fast as she's switching.
36 months is how many years?
3 years.
How many?
3.
3. Okay. So put your 3 there. And what did you get for your answer? Somebody want to tell me?
I get it first card. This screen was switching too fast. You couldn't even write.
Okay, now, all right, okay, let me
Okay.
do this because I know going back and forth is kind of a problem. So, okay, so let me just do this. Okay,
Miss Barbara, this is what? I don't find this in my
you don't
email.
you
You
don't
said it's
find what?
10,000?
Yeah,
Because it's not,
You don't find what, Chastity?
10,000?
it's part in the email. Do you send
No,
this?
this is not gonna be in your email until I send it to you after the session.
Oh, okay, okay.
This is new.
All right.
I'm going through compounding,
All right.
you know, interest. This is okay. I'm doing exponential growth and decay, but I'm starting with compound interest formula. And this is new. This would not be something I would have sent to you, but you will get all of this at the end. Okay. So let me just go back here. Okay. So I'll just put here A. This is what you want to get. So that's 10,000.
Right.
All right. So I'll just make that bigger. I'll put the values here. Okay. Now the rate is what?
0.035%.
Yes, that's the rate is 3.5%. And as a decimal, is what you said, Audrey, 0.035. So you've got that, right? There we go.
Yes.
So I'm putting these values in, and then I want you to put them in the formula. Okay. And the N, what is the N?
The N is 12.
N is
It's
12
a
because
month.
we said monthly, right? N equals 12 for monthly, right? I gave you those
Mhm.
values at the beginning, what the N values are. So this N is 12. So let me just put the little n to be consistent. And what's the T?
T is the time.
36 months.
Okay.
T is 36 months because they say in 36 months time. So that would be 36 months. And that's how many years, Audrey? 36
months.
36
a year
months,
and
how
a
many
half.
years?
2 years and a half.
No,
Right.
12 months is a year,
How much is a
3
year?
years.
3 years.
Yeah, another 3 years.
All right, so now you've got everything you need to substitute. Let's see, put that, let me make that bigger. Okay, so you've got everything you need to substitute, and I want you to tell me what the formula will look like. I want you to substitute in this formula and tell me what goes where. Anybody want to do it?
1,000 plus 1.
Okay, so what would you have, Audrey?
I have the 10,000,
Okay, 10,000, very good.
and then you have the
Equal.
parentheses.
No, what
Equal.
goes next?
Plus
35%.
No,
No.
P.
5. T.
In other words, how much
Increase.
do you want to invest to get this 10,000? So you don't know the P.
Yeah.
That would be something you would be solving for, right? Now what goes
Mhm.
next, Audrey?
Plus the 0.035.
No, you got a 1 here.
Right. Okay. Yes, the 1. Right. So the 1
1
first. Plus
plus, that's right, very good.
0.035.
0.035, your rate converted to a decimal, and that's over what?
12.
Over
Okay,
12, because we said monthly, right? Now, what's the power?
The 12 is 36, 3 years.
So NT
Right.
would be 12 times 3.
36.
Because that's the time, 3. So if you solve this, you'd solve for P, and P would give you how much you need to invest in order to have 10,000 in 3 years, compounded monthly at a rate of 3.5%. Questions? Any questions? So I want you to be able to, we won't be calculating these so much as setting them up, being able to recognize a correct setup for being able to set them up using the interest formula. So now you know what the interest formula is. The first one, I think we were looking for the amount you would have given a starting amount. This one, you're given an ending amount and you want to find out what would be the starting amount, P. Questions? All right, did everybody
go
have
over
this
that again?
correct? Yes. Audrey?
Yes. Yeah. Wait a minute.
Audrey, question?
Yeah. I was saying to go over that last part that you said.
Right here? Oh, what I was
Uh-huh.
saying is, this is what you want to gain. This is what you want your, but not gain. This is what you want your amount to be. This is your ending amount. This P is your starting amount. In this setup, you plan to need 10,000. So you want 10,000 to be your ending amount. What must you put as a starting amount to get an ending amount of 10,000, investing at a rate of 3.5% for compounding monthly for a 36-month time period? Got it? Questions?
No.
Okay, so you understand the formula, and I think let's go back here. Okay, here are all the descriptions. A is the ending amount. P is the beginning amount of principal. R is the interest rate. N is the number of compoundings a year. And T is the total number of years. So you know what, that's the important thing, is to know what these are in the formula. In other words, everything that's within the formula has a meaning, and you should know the meaning. Ending, beginning, interest rate, number of compoundings, number of years, T. That's why we took the 36 months and converted it to years. 12 months in a year, 36 over 12 is 2. T is always a number of years. And if it's given in something else, you must convert it, okay? All right, let's look. I think we have another. Okay. Now, here is a, okay, this is a decay. That was, you were making money on this one. This one, you actually
Losing?
Yeah, you're losing. And this is, well, anybody familiar with decay? That's particularly used with radioactive substances. It decay over a period of time, right? So you have a radioactive substance decaying at a rate of 3.5% per hour. So that's your rate of decay. What percent of the substance will be left after 6 hours. Now, since we don't know how much we're starting with, and this is really based on percents because it's 3.5% per hour, we'll just make an assumption that we're starting with 100. All right. So to find the percent after 6 hours, you would have what? 1 minus the
Yes.
3.5% converted to a
3.5,
decimal. There
okay.
you go, right here. All right. Let me make this bigger. Okay, so convert the percent to a decimal. 1 minus 0.035. The time is 6 hours. There we go. That's the time. Let's underline that. So 100, we make an assumption we have 100 as our initial amount. 1 minus the rate converted to a decimal raised to the 6 power. Let me just take this out. Okay, and since this was 6 hours, the time would be 6 hours. So this is the way it would look. Subtract the 0.035 from the 1.965, raise that to the 6th power, that gives you 0.8075 times 100. So that would be, that means you'd have 80.75% of the substance after
Yes,
6 hours.
hours, yes, I get that.
Yeah, you got it? Any questions
Yes.
on that?
8.75.
Okay. So that's a decay. So decay means it's decreasing, right?
Increasing, yes.
All right. So you could have increasing, or you could have decay, decreasing. Now, looking at inequalities again, and I think I said this before, but I want to say it again. 5 inequality symbols. There they are, right there.
Yeah.
Okay. And what are the 5? Anybody want to tell me in words? What are the 5 inequality symbols?
Greater than, less than, equal to.
No, equal is not inequality.
Oh,
Right?
less than.
That's an equal. Audrey, you give him an equal. No, inequality is mean you
Yeah.
don't have an equal. You have a greater than, a
Greater
less
than, less than.
than, greater than or equal, less than or equal, and a not equal.
Okay.
All right, there you go.
There.
5 inequality symbols. Greater than, less than, greater than or equal, less than or equal. 4 greater than or equal to 2x, right? So if 4 is greater than or equal to 2x, can x be equal to 2? Yes. Yes, because it says greater than or equal. And 2 times 2 is 4. 4 is equal to 2. Less than or equal, we say 6 is less than or equal to 2 times x. So what can x be? X can be a 3, right? Because 2 times 3 is 6, and 6 is equal to 6. X can be 6. 2 times 6 is 12, and 6 is less than 12. Got it? Okay. Or you could have not equal. 6x is 36. X is 6. 6 times x greater than 12. X could be 3. 6 times 3 is 18. 18 greater than 12. Now the not equal is pretty straightforward. 2 cannot be equal to 4. Right? Never. 2 is not equal to 4. 5 is not equal to 6. 10 is not equal to 12. That's a not equal. Okay. Now, we will basically be looking at linear equalities, and we've been solving these, okay? and LHS, that's left-hand side, right-hand side. And we've been solving them. Now, if you have a negative, okay, and I think I put a negative here. Okay, let's see if I have the negative. Okay. Okay, let me go to, okay, x plus 2 greater than 12. We've been doing some of these, same thing, right? So we subtract the 12, the 2 from both sides, we get what? X greater than
Plus
10.
two.
That's
Yeah.
it. Yeah, subtract the 2 from both sides. 2 from 12 is 10. It becomes x greater than 10. Here's another one. 3y less than 15. What did we do with the 3, Audrey? It's a multiplication, so what do we do? Audrey? We divide, right? Yeah, divide by 3. So we divide both sides by 3 and we get y less than 5. There's your answer, less than 5. Okay. Now, here's one that has negative. X minus 3 over 2 less than or equal to minus 5. Now, we multiply, now this is division, so we multiply both sides by 2, right? This becomes x minus 3 less than or equal to minus 5 times 2, which is a minus 10. So x minus 3 less than minus 10. Add the 3 to both sides. What does this become? X less than or equal to minus 10 plus 3. What do you do when you're adding negative and positives? You subtract. 3 from 10 is 7. The 10 is the biggest, so your answer is a negative 7. Okay. But what happens when you multiply or divide both sides by a negative, you switch the direction of the inequality. So if you multiply this by negative, then this is not less than, it becomes greater than. Okay. And if you change the sides, then you reverse the inequality. So minus 2y less than minus 8. So y is greater than 4. Okay, because we divide here by a negative. So divide and multiply by a negative, you reverse the inequality. So the less than that's here becomes a greater than in the answer. Now, this becomes clearer when you do some of these, okay? But just remember, if you're multiplying or dividing by negative, your inequality is reversed. So if it was less than, it becomes greater than, okay? If it was less than or equal, it becomes greater than or equal. That's what we mean by reverse. Questions? Now, I know we're going pretty quick here, but you'll get some of these to practice on. And I won't be giving you any of these until we do some more examples, okay? Here, when you swap, if we try to put the y on the other side, we change this. It wouldn't be greater than, it would become less than. All right? Any questions on what we've looked at? I know I kind of went through it, but you'll get all of this, and maybe when you see it, it starts making sense, but we'll do more examples. But one other thing I just want to mention, and we won't be getting into that until later, but I just want to mention that we have what we call compound inequalities. That means and or. So you could have two inequalities together, and or you can have or. Okay, so x less than 3 or x greater than 5. That's the or. The and x greater than 0 and x less than 4. And I'll show you a way to do those where you can just do them separate. Do one and then do the other, and then you put them together. Okay. Now, I drew some number lines here. Now, whenever you see, just something to say here, whenever you see a greater than or equal, less than or equal, that means it includes something, and that's what we call a closed circle. And you'll see it shaded, a shaded circle. And if it's greater than or it's less than, then it's an open circle. Okay, so I
Less
want you to
than
be,
is open circle.
yeah, the open circle is greater than and less than. But if it's greater than or equal, less than or equal, then it's a closed circle, because it's saying it's less than, it's greater than or equal, or less than or equal. So that means the equal makes it closed, all right? Whereas it's either greater than or less than, then that's an open, okay? So you'll later see some number lines and you'd identify which inequality they have. And you can do that from looking at well, you can do that by looking at the number line. Okay, so like here, closed circle, greater than or equal, less than or equal. That means the equal, it includes that. The open circle does not include the value. So like here, where you see this number line, see that arrow? So the 2 is included here, right? The 1 is not included here, okay? So when you see that closed or shaded circle, that's a greater than or equal or less than or equal. That's the easiest way to remember it. If I give you a number line and it has a shaded circle, then the inequality has to be a greater than or equal, a less than or equal. If it's an open circle, then it's got to be a greater than or a less than. Does not include the value. Okay. So those are some rules that we've been looking at. Now, you will not get any assignment on this because we have to go through some more of these, but I just want you to be aware that there are simple inequalities and there are compound inequalities, okay? And we'll get into some examples of these, but I just want you to know that all inequalities are not simple. Some of them are compound. They can be an or they can be an and. All right. So the assignment would just really be on simple inequalities. We'll get into compound inequalities with examples, and then you'll be able to do some. But the homework that I'll be giving you for the next time will just have the simple inequalities, okay?
Mhm.
The simple inequalities and the setup of the compound interest and the decay type problems where you have to subtract, okay, the rate. Questions on anything we've gone over? Okay, just remember when you send the work, you don't have to send it all, you can send whatever you've done. All right, and
Okay.
I appreciate you sending it in.